Okay, let's have more example before you wrap up our activity today. Okay, so let's have an example of naming this.
Wala siya nag-uan?
Okay, let's try to practice naming this one. Okay, so naklaro ba ang screen? Naklaro ninyo akong screen? Hello, everyone. Naklaro ninyo akong screen?
Wala pa, ma'am.
Wala, ma'am.
Pag mag-discuss ganito ko na ninyo makita na may reklamo, you really have to tell me. Kana, what about this? Naklaro?
Yes, ma'am. Claro.
Okay, so let's have a practice now before you start your activity. Let's have a practice naming our hydrocarbons. So anyone, when we name, we always start, as I mentioned earlier, with how to identify our parent chain, or the one that contains the longest continuous carbon chain. Continuous yung ulay putol sa carbon, no? And before the parent chain is our subsequent. So can I ask a volunteer to identify our parent chain and how do we name? Budget lang. So can you look at this and I will be back. Hello, so I'm back. Anyone can identify what is our parent chain here?
Heptane, ma'am.
Isa to. What is the parent chain? Then start counting from the left. Anyone? Any volunteer for our parent chain? Anyone? Huh?
Heptane.
Heptane? We start counting 1, 2, 3, 4, 5, 6, 7. So our parent chain is heptane. And our substituent, anyone?
3-methyl, ma'am.
Huh? Our substituent,
3-methyl,
we first identify it's methyl, and we also have,
ethyl.
yes, we have methyl, and we also have our ethyl. All right, so our methyl, if you start counting from the left, you have start counting from the left is carbon 1, carbon 2, carbon 3. We have carbon 3 here. This is our carbon 4. Start counting from the right. We have carbon 1, 2, 3, 4 also, and 5. Now, when we name our substituent, we always alphabetize. Okay, so before methyl, we start naming our ethyl. Okay. So when we name this one, we first have to mention our ethyl before methyl. Okay. And our ethyl is located on carbon 4. Start counting from the 1, 2, 3, 4. Start counting from the 3, 4, 5, 6, 7. All start counting from the left and right. It's methyl, it's ethyl. So we always alphabetize our substituent. This is the general rule. And then we choose the lowest locus. So for ethyl, you have 4 on the carbon 4, and methyl is on carbon. Can have 2 options. No, you have 4 ethyl, and if it's from the left, it's methyl is on carbon 3, right? Another way is if it start counting from the right, you still have ethyl and methyl. Okay, if it's from the right, ethyl is carbon 4 again, but methyl is on 5. Okay, see the first point of difference, right? So we choose the one having the first point of difference. So the lower location for all the substituents, you have it on methyl. Okay, first point of difference, ilaha. So it's 3 methyl. So we choose this one here. Choose this one. Okay, so when we name this, our name is, we copy 4-ethyl. First name the parent chain heptane, and before heptane is our substituent, which is 4-ethyl 3-methyl heptane. Okay, walay space. That is how we name this one. Okay, what else? So the name for this is 4-ethyl 3-methyl heptane. This one, number 2. What is our longest continuous carbon chain? And second one. What is our longest continuous carbon chain here? Anyone? How many carbons?
Pentane.
Pentane. Okay.
5.
From the left, you have 1, 2, 3, 4, 5. That's pentane. We start down, counting 1, 2, 3, 4. Start from the right. 1, 2, 3, 4, 5, 6. You can have from the right down, right? So, on man, 5 or 6? Wala ninyo na consider this one, kani.
5.
Sorry. Pag this lang, from the left, that's 5. Pag pababa, that's 4. Pag yellow, this direction, you have 1, 2, 3, 4, 5, 6, right? So pila man? 5, 4, 5, 4, 6. Of course, we choose the longest continuous carbon chain. Are you following me? So you have the hexane. Klaro ang yellow. Okay, and our substituent, since this is our, the yellow one, this is our parent chain here. Since this is our parent chain, kanigin circle na ako yellow, then our substituent, katong wala na appeal, this one, CH3 is our substituent. All right? So, on sa mga CH3, that is simply our, what is CH3? The one carbon, and the word met, or substituent is, anyone? Yes, our substituent is methyl. But methyl is located in which carbon? Start counting from, kanima ng yellow, no? Start counting up, down. There is a right down. Okay. Okay, let's start with yellow. You have 1, what am I using? Sige, gray. 1, 2, 3, 4. This is carbon 4. But if you start counting from kaning pababa, okay, that is just 1, 2, 3. So between 4 methyl, oops, between 4 methyl and 3 methyl, sa itong pilion, we choose the one with the lower local. Okay, so for our name, it will become parent. Again, start with parent. You have your parent chain. Before that one is your substituent. So you name again. Okay, so how we name? Of course, we start with our hexane. For the hexane is our substituent, which is 3-methyl hexane. So this is our name. Am I clear to you? Do you have questions? Okay, so the name this is 3-methyl hexane. It's very simple. What else have I forgot? When a substituent is attached to a hydrocarbon containing a multiple bond, numbering should start at the end, which gives the lowest number to the multiple bonds. Okay, yeah, I've already mentioned that one. And there is another one. If more than one double bond or triple bond is present, the compound is named as diene, triene, or equivalent prefix. For example, here you have 1, 2, 3. That should have been hexane, but since hexane rather, no, there is a double bond, but since there is, we should have named this one as hexene. Okay, but since there is a double bond, like our prefix is hex and we should end with "-ene" since there are two double bonds, so we have to include di, no, di before our "-ene." A parent chain is hex, and we should have an "-ene" here, but we need to include a di before "-ene." Okay, and we need to indicate where is the "-ene", kaning duha ka "-ene. So it's located, if we start counting from the left, it's located on carbon 2, the 1, 2, 3, 4, it's carbon 2 and 4. We start counting from the right, it's located on carbon 2 and also carbon 4. Okay, it's 2, 4, hexadiene. Dili pwede magsunod ang both consonants. So you have the include the hexadiene. And then of course it's from the left. If we start counting from the left or from the right, we always ends up with 1, 2, carbon 2, 3, 4, 2 and 4 gihapon. If we start counting from the right, it's carbon. It would also be 2, 4. Naka-record ako. Huli naka-record ko na. And then what else? But the first point of difference, now you have 2,4-hexadiene and you will have your methyl. Start counting from the left, your methyl will be on 1, 2, 3, 4, carbon 4. If you start counting from the right, it will be on 3 methyls. Since the direction left and right sa atong parent chain is the same, either way, you always choose the first point of difference. Okay, so our substituent, since that will be our parent chain, either way, we count from the left or for the right, we always choose the first point of difference. Okay, so you have your 3-methyl 2-hexene, not 1, 2, 3, 4. Okay, what else? Hydrocarbons can also form rings, no? For example, you still count on the number of carbon atoms. So a ring, a cyclic compound, we call that one a hydrocarbon that forms a ring. We call that one as alicyclic compound or cyclic compound. Simply cyclic compounds or alicyclic compounds. We count by the number of carbon atoms still involved, no? Or the number of carbon atoms in the structure. And in this case, the first carbon is connected to the last carbon. So if you start counting here, carbon 1, 2, 3, the third carbon is connected to the first carbon. That's what makes it cyclic. When we name, this will name based from the number of carbon atoms for the parent chain. So for this case, you have 1, 2, 3. That should have been our, make it red, propane. Okay, propane, but we add a cyclo prefix, so that's cyclopropane. So this one is not butane, so I'm not delete this one. Cyclobutane should have been 4, so let's go. This one is 1, 2, 3, 4, 5. This is named as cyclohexane. Okay, there should be another one here, and this one is, there should be a bond here. And this one is 4, so that will be butane. Okay, but there is a double bond here, butane. This is our parent chain. Make it red and put the word cyclo before the butane. Cyclopentane, this one is pentane. But again, include the pentane, before, a cyclo rather, before the name. This one is 1, 2, 3, 4, 5, pentane. Name this as pentane, but there are pentene rather, since there's a double bond, but there are two. So you call this one as pentadiene. Okay, di to indicate that there are two double bond, and you start counting from carbon, just any carbon having the double bond. So that would give the shortest one. So start counting from here, you have carbon 1, 2, 3, 4. Okay, so it's carbon 1. And in carbon 3, there is a double bond. So 1, the first carbon of the double bond. So start counting from here, you have 1, 2. On carbon 1, first carbon that contains the double bond, so that's 1. Okay, and then you have on carbon 1, 2, 3. On carbon 3, you have another double bond, and that's 3. So that is where your di is located. Diene located. Okay, and then if you have other substituents, you have 1, 2, 3, 4, 5, 6. That's hexane. That's our parent chain. But since it is cyclic, so we include cyclo in our parent chain. And then you have your substituents. Your substituent here is methyl and chloro. So we alphabetize. It's chloro or methyl. We start with chloro first, and then methyl. So chloro, first point of difference, this becomes our carbon 1. So chloro 3-methyl, because you can also start anywhere, but we always choose the one with the first point of difference with the lowest low cut, lowest number of low cut. So 1 chloro and methyl, mag-unagit si chloro now. We first name our substituent always in alphabetical order. Okay, so that's why you have 1 chloro 3-methyl. This one, you have 1, 2, 3 cyclopentane. This becomes our substituent, so 1-ethyl cyclopentane. And here our parent chain is the one with the longest continuous carbon chain. So instead of the cyclic, since there are 4, then a straight chain, which is pentane, becomes our parent chain. So we have your 1, 2, 3, 4, 5, that is our parent chain. Red, pentane. Without a cyclo, and the one that is a substituent is our cyclic one. So 1, 2, 3, 4, which is cyclic, so you call this one a cyclobutyl. Okay, and cyclobutyl is located on carbon 3. Okay, it's very simple. And then when we start structure writing, the first one is we always start with the parent chain. Again, as I've mentioned earlier, when we name, mag-una si substituent, ay si parent chain. So when we look at the naming, for example, let's say here as an example. Example, you have 2,4-tetramethylhexane. So our parent chain is the last one. Okay, so you look at the last one, because when we name, always remember, when we name, it's always the parent chain, the last, and before that one is our substituent. Remember, that's how we name. So the parent chain, and before the parent chain is our substituent or substituents. Okay, so here, tanaw na tong nasa last. So kani siya becomes our, underline na lang na kani siya, parent chain, no? And the one nga wala sa parent chain, katong before the parent chain, is all your substituent. Okay, so in this case, makita na to, we have here in the example, you have 2,3-tetramethylhexane. So our parent chain is hexane, katong nasa last. And for the parent chain are all our substituents. So hexane, so we draw the continuous 6 carbon atoms, 1, 2, 3, 4, 5, 6. And on carbon 2 is our methyl, on carbon 3 is our methyl, and on carbon 4 is our methyl also. Okay, carbon 4 is another methyl, carbon 5 is another methyl, and then after that, you add all the hydrogens sa atong carbon. So it includes 3 hydrogens here, one hydrogen, 3 hydrogens to satisfy the octet. Okay, that's very simple, and you can write the structure in this using the Lewis formula where you show the bond, or you can do a shortcut where you show we have the condensed structure, no, or not so condensed structure, or you can do zigzag structure. Okay, for example, you have 2,4-dimethylpentanes or parent chain, make it red, is pentane, then underline, so you zigzag 1, 2, 3, 4, 5, and the blue, let's make it blue, is our substituent. Okay, and our substituent is methyl, so 2,4-dimethyl, duha ka methyl. So on carbon 1, 2, there is methyl, 3, 4, on the 4th, there is also methyl. So you can do zigzag, or you can do the condensed Lewis structure or the Lewis structure here. So you have CH3, C, 5 carbons. On carbon 2, you have CH3. On carbon 4, you have CH3. Then you satisfy all the other hydrogens. Okay, that's how very simple we write these structures. Chloroheptane, no? 3 chloroheptanes are parent chain, red, underline, the other one blue. So heptanes, just zigzag 1, 2, 3, 4, 5, 6, 7, and on carbon 3, 1, 2, 3 is chloro. It's very simple. Or you do this one, no? CH3, CH2, 3. Carbon, 7 carbon, and then in carbon 3 you have Cl, and then satisfy the hydrogens. Very simple. Yes, do you have any question? Okay, let's start. This one will end in 10 minutes. So I think I have already discussed what needs to be discussed for your activity 2. And you can go back into this introduction if there's something that you forget. Okay. Do you have questions? Do you have questions? So for our discussion, I think I will upload this also, and I will update. There are corrections. I'll also update the one in here. So today is 14, and the due date is next week. No, so for today is Monday. Thursday, you also spend time on doing your activity. And of course, you just need to do the attendance. No, on 21, we'll have another discussion on Monday. Okay. Do you have questions? The meeting will end, I think, in a few minutes, less than 10 minutes. Do you have questions?
Wala na.
Or you can ask me question as you answer your activity, okay? So since there are two parts of the activity, you have your answer sheet. There are two parts in your answer sheets, no? The first part is the nomenclature, the name. The second part is you write the structure, makita ba? You write the structure based from the name. Okay? So for today, you can start doing the, you still have 1 hour kapin, you can start doing the naming, okay? And then for Thursday, you can continue naming and you can continue writing the structural formulas, no? The reason why we include this one in the laboratory course is because sometimes it will take time really to digest everything. No, it needs practice, so you need longer time to develop that skills of nomenclature and also writing the structure. So you take your time up until Thursday, and then Thursday and the next Monday, you submit your activity. If you have questions and if you need to meet, I will probably send a Zoom link where you can do a group discussion. Probably I'm gonna, if you want, I can give a breakout rooms. Let's see. Probably great. Okay, next meeting, we can create breakout rooms now if you need to discuss with your classmates. And for the remaining time, still have time, you can discuss with your classmates. And so I have already grouped you. There's only 8 and I don't know where are the others. And then you can make a discussion with this one. Create. Kita na ba ninyo ang kuan? Ang breakout. Okay, you can join the breakout rooms and there's only 2 breakout rooms, no? You can go there and discuss with your classmates. Regarding the activity, and of course, you will have to submit individually and you will have to do it individually, you know. You can ask for help from your classmates if for a discussion. You can also ask me if you want. So there's a breakout room, you can join there. And join in there. We have 5 minutes to discuss with your classmates and you can work on there. Okay, if you're done discussing with your classmates and